Hello guys, welcome back to Techdose, and in this video we will see the merge intervals problem, which is from Leetcode number 56, and this is a greedy type problem. After discussing the intuition and the solution to the problem, we will look at the most important follow-up problems which you can get in an interview. So stay tuned till the end of the video. I would like to announce about our DSA live training program, which will guarantee understanding of every programming concept. It makes you interview ready in just 3 months. And it will maximize your offers so that you get the best possible pay and in the best possible company you can. All the sessions will be live interactive sessions, so you will get the feel of a live class and you can ask all your doubts throughout the class. In order to get more details, please WhatsApp us on this given number. Let us now look at the problem statement. In this problem, given an array intervals where intervals consist of two items start at I and end of the interval, which is end I, merge all the overlapping intervals and return an array of non-overlapping intervals that cover all the intervals in the input. Now let us look at an example for better understanding. In this case, you are given an array of intervals, right? So you are given, let's say 1, 3, 3, 6, 5, 8 and 10, 12. If you need the visual representation, this is how it will look like. So 1 to 3 is an interval, 3 to 6 is another interval, and 5 to 8 is yet another interval. And then you have 10 to 12. Now if you merge all these intervals in such a way that all the overlapping intervals merge into a single interval, then you will see that 1 to 8 will become a single interval because there is something in common. It will always be continuous. Like if somebody is standing at this point and you are getting the top view, right? If you are doing the top view of this entire figure, then all these will seem like a continuous line if you are doing the top view, and hence it will merge into an interval of 1 to 8. But since there is a gap in between 8 and 10, hence this will create a different interval from 10 to 12. So this is the XY plane. All these are actually on the x-axis. So the question may ask you about how many of these different intervals you have formed, like how many independent intervals are there. So there are two independent intervals, one from 1 to 8 and another one from 10 to 12. Or it can also ask you to find out the exact intervals after merging. Now let us look at the possible solutions for this problem. Now one possible solution can be, let's say the intervals are given and there are 4 intervals. In this case, if I take the current interval as this one, let's say this is my current interval, which is 1 to 3, and if I keep comparing all the adjacent intervals in such a way that if the adjacent intervals are overlapping, then I will include it in the same interval. Now the first condition is, how do I check two intervals and consider them as overlapping or non-overlapping? Now let's see. For the first interval, my start of the interval is 1 and my end of the interval is 3. Now if I have to check the current plus 1th interval, that is the next interval, which is from 2 to 4, you have to see that if the start of the second interval is actually less than equals to the end of the first interval, right? So if this 2 is less than equals to 3, then it must be overlapping if this 4 is greater than equals to this 3, right? So if the end is greater than equals to this end value, which is E, and the start is less than equals to E, then definitely there is an overlap. And what can be the overlap value? The new merged interval will be, the starting point will be taken as the minimum of the two starting points, and the end point will be taken as the maximum of the two end points, which is E and end, let's say that. And this will be the new interval. So if you follow this, then it will be the minimum of 1, 2, and the endpoint will be the maximum of 3, 4. And by this rule, you will get an interval from 1 to 4 as the new merged interval after merging 1 to 3 and 2 to 4. And you can visually see that it will be the answer. So you will get a new interval where the start point will be 1 and the end point will be 4. Now your current will shift to this point, and this point will now have start equals to 1 and end equals to 4. Now we will be comparing this to the next interval, 4 to 6. Now let's see this. 4 is already less than equals to 4, correct, and 6 is greater than equals to 4, that is also correct, hence they are overlapping. So the new start point will still be 2, which is the minimum of 2, 4, and the new endpoint will be maximum of 4,6. So this will be updated to 6. So after merging the 3 interval, that means the third interval as well, you get a single interval 1 to 6. Now your current will shift to this point and you will now be checking with the next interval. So this is from 8 to 10. Now let's look at it. Is this interval overlapping with the current interval? The current interval is from 1 to 6. Now 8 is not less than equals to 6. 8 is actually greater than 6. And if the start point of the next interval is less than the previous end point, then definitely there is a gap and this interval is not overlapping. So this now becomes one of the merged interval and you have to restart another interval starting at this point 8, and you will assume that 8,10 is the current interval and the current will shift to this point, and now you will be comparing with the next interval that is not present in this case. Hence, after doing the merge interval solution, you will get 1 to 6 and 8 to 10 as 2 independent intervals after doing all possible merge operations. This approach is very important. We will be using this approach throughout the video. So if you didn't understand this approach, please rewind the video and do it again. This is an order of n solution where n is the number of intervals present here. So this solution works for this example, but is this solution going to work for every possible example? Let's see a counter example for that approach. What if the intervals are unsorted? Basically, the previous case works for sorted intervals. But what if the intervals are unsorted? Because the problem doesn't guarantee you have the sorted intervals, right? So if the intervals are unsorted, let's say from 1 to 3, 5 to 8 and 2 to 7. If you again apply the same process, let's again apply it. You have the current interval start point as 1 and end point as 3. Now when you compare it with the adjacent interval, the next one, which is 5 to 8, I have just given the visual diagram. The top to down is the actual flow. Okay, so the first interval is 1 to 3, second one is 5 to 8 and the third one is 2 to 7. So if you compare this, you will see that the 5 is greater than 3, hence they are not overlapping. So 1, 3 will be declared as an independent interval and now you will be restarting a new interval with 5, 8. So the start point will be 5 and the end point will be 8 and this will be your current. Now you will be checking with the current plus 1th interval, which is this one, and you will see that there is an overlap. And the overlap actually updates the start point to 2 and the end point remains as 8. So this will be updated to 2, 8. Now after doing the merge operation using approach 1, actually the previous approach I'll call it as approach 1. So doing the approach 1 on this particular example will give me 1 to 3 and 2 to 8. But you can see that the answer should have been 1 to 8 as a single interval, but this is giving me 2 intervals, which is wrong. So we know that approach 1 alone cannot solve the problem of merge interval. So we have to come up with something else. Now the possible correct approaches for the previous problem is, one thing we can do brute force, which is creating all possible combinations and getting the result. And the second approach can be doing the sorting algorithm. And by sorting, we mean that we can sort based on the beginning of the interval or the end of the interval. So interval has 2 points, begin and end. So we can sort based on the first value or on the second value. We will see both the solutions, but let's first see how the brute force solution would work. So let's take the same example and we will try the brute force solution. The brute force solution is nothing but applying the approach 1 n number of times. That means if you keep applying approach 1 the interval number of times, then you will definitely get to the result. Why didn't we get our result in the previous attempt? Like in this attempt, why didn't we get the result? Because we just did this process only once. This is the first time we are doing it. But if we repeat this process, keep repeating the process n times or n minus 1 times, then we will definitely get to the result. Like if I repeat it the second time, then I will get 1 to 8 because this will be the current value. And if I check with current plus 1, then definitely I'll get 1 to 8 as the result. So if you apply it only once, then it will not work for the unsorted intervals. But if you apply it n number of times, approach 1, then it will definitely work, right? So that is the brute force approach. And this is the visual representation of the previous example using the brute force approach. So in approach 1, you will get 1 to 3 and 2 to 8 as 2 different intervals. And after that, if you apply the approach 1 as the second time, you will get 1 to 8, which is the correct answer. Approach 1 actually takes order of n time. And if you apply it n minus 1 or n times, then that becomes order of n square solution. That is the brute force solution. But this is not the expected solution in the problem. If you look at the constraint, then the constraint expects something else, right? The interval's length are 10 to the power 4. So if it is 10 to the power 4 and you are applying n square, then it will go to 10 to the power 8. But your solution should run below 1 second. So it should be below 10 to the power 8. So something better than n square will be accepted. So let's try to apply the sorting algorithm. Now the sorting can be of two types since we have two values, starting and end value. So let's start by discussing sorting by end value. That is the second value. So let's take the same example, which is example 1. And in this case, the end values of each intervals are 3, 8 and 7. If we do sorting by second value, then we get 1 to 3, 2 to 7 and 5 to 8. This is sorted by end value, right? Now if I apply approach 1, like taking the current here and trying to merge in order of n time, I hope you know this by now, then you will get the answer as 1 to 8 and the time complexity will be order of n. For applying approach 1, for sorting it was n log n. So these are two different independent steps. So the total time complexity will be n log n plus n, which will be n log n, right? And this works for this example. But let's try to take a counter example. In example 2, I have taken 1 to 3, 5 to 8 and 2 to 9. If you sort by the second value, then you will get 1 to 3, 5 to 8 and 2 to 9. Now if you apply approach 1 solution again, which is order of n merging, then you will see that you will get 1 to 3 as a different interval and 5 to 8 will be merged with 2 to 9 and hence you will get 2 to 9. So it will give you two different intervals, 1 to 3 and 2 to 9, but actually the answer should only have been 1 to 9. So this sorting by end value doesn't work, right? Didn't work on this example. So if you can come up with at least one counter example, then you can actually nullify that entire algorithm, whatever you have chosen. Why didn't it work? This did not work because we need a guarantee that if we have seen an interval starting at some point S1 and ending at E1, the next interval should not have a start point which is less than S1. That should be guaranteed, and that cannot be guaranteed if you are sorting by the end value. Therefore, let's try to do the same thing by sorting by the start value. So I've taken the second example, which was the counter example in the previous case, and let's try to solve that problem. 1 to 3, 5 to 8 and 2 to 9. If I sort by the first value, which is 1, 2 and 5, then I'll get 1 to 3, 2 to 9 and 5 to 8. And if I again apply the first approach, that is linear time merging using the current variable, then you will get 1 to 9 as a single interval in just one step. So here the time complexity is n log n, and this solution is bound to work for any type of example, unsorted, sorted, whatever it may be, it will always work. You will not be able to come up with a counter example. So this is the expected optimal solution for the merge intervals problem, and I hope you have understood why other solutions don't work and why this solution is working and why the time complexity is n log n. Let's quickly look at the follow-up problems and then we will look at the code. So the first follow-up problem can be printing the merge intervals. If your problem was about finding out how many independent intervals are there, then the follow-up can be print all those intervals. And if your problem was about printing all the merge intervals, then the follow-up problem can be print how many of these merge intervals are there. I mean, how many of these independent intervals are present. The second follow-up problem can be printing the non-overlapping intervals. You can practice this by going to Leetcode number 435. And the third follow-up problem, which is slightly related to this same problem, is the minimum platforms problem. And you can do this by watching my video on minimum platforms. You can search on YouTube. The link for it will be given in the description below as well. Now let us look at the code for the merge intervals problem. In this problem, we are given the 2D intervals array, and I have found the number of intervals in n. Then I have sorted all the intervals based on the start point. So by default, your library will sort based on the start point. And then we have taken the answer intervals, which is the all possible merge intervals, and simply we will apply the approach 1. So this is basically approach 1, where we have chosen the start point as the first interval and the end point as the second, the first interval's end point. So this was 3, I guess, in the previous problem. And then we will be iterating through all the adjacent values until we don't find any gap. and that particular start and end value will be merged into our list of list which is in the answer. So you can go through this code, and I think if you have understood approach 1, then this is the code for the same approach applied along with the sorting. So this is the sorting step in just one line, and after that it is just approach 1. The PDF of this video will be present in the Telegram group, so you can follow us on Telegram to have all the previous videos PDF as well. You can follow us on Instagram as well to get updated with all the interview trends. I hope this video was helpful. See you guys in the next video. Thank you.